Today, we are going to build our very own custom advisor in Spring AI with a very specific purpose. Now, I've done a video on advisors. I'll leave a link up here or in the description below. If you want to learn more about what advisors are in Spring, the TLDR is they're kind of like AOP functions where you can wrap a large language model call and do something with it. Now, the reason this came up is I was recently at a conference, Dev2Next in Colorado Springs, wonderful conference if you ever get a chance to go. And I was in a presentation and they were talking about the chat memory advisor that is in Spring. This was actually a comparison between LangChain4j and Spring AI. And somebody asked the question like, well, what happens when you reach like the number of max messages? Where do the messages go? And they just clear out, right? I use tools like Claude Code, and when I'm using that, as the context window begins to fill up, I can call /compact on that and basically summarize what's been in the context window and get it summarized down to a smaller bit so we're not like storing all of this information in the context window. You can also clear and basically just start over. So there are some different things you can do there. So, and it got me started thinking like, well, we don't have that available in Spring AI right now, but there's nothing stopping me from building my own advisor that does that. So I threw some things together, hacked some things together, and got it working. Now, this is just for fun, a rough prototype of how things work. I'll actually talk with the Spring AI team and see if this is something we can add to it. But right now, it's just a project that I thought I would throw together. So again, the way it works is you will have some number of max messages. When we reach a threshold, we will automatically compact that. So we'll take a percentage of those messages and hand that off to an LLM to go ahead and summarize the conversation. So we can take maybe 15 of those messages, bring them down to 1, which saves us a lot of tokens and kind of clears the context window out. So it was a lot of fun to build. I'm going to share that with you today. We'll go through and create the project. I'll write some code, I'll paste some code, but you'll see how this kind of project came together, and hopefully you find it useful, not only for like building your own Spring AI advisors, right? That's great. But in this specific case, the compacting chat memory advisor. We'll see if that's something useful to you. So with that, let's go ahead and get into it. All right, so if you're interested in this repository, I will leave a link to this in the description below. We are going to code through some of this. I'm gonna like paste some code in. We're not gonna write every single line of this together, but this is the result of what we're gonna go through today, the compacting chat memory advisor for Spring AI. So let's go ahead and get started. I'm going to create a Java project using Maven and the latest stable version, which is 3.5.6 at the time of this recording. We're going to say dev.dan Vega compact chat memory. So CCM, I guess. That sounds good. And then I'll go ahead and I'll add a couple of things. I'll add the web support and I'll also add OpenAI. I'm going to use OpenAI for this. You can use whatever large language model you want. That should give us everything we need. So let's go ahead and generate this project, download the zip, and open it up in whatever IDE or text editor you're most efficient in. I'm going to use IntelliJ, and with that, let's write some code. All right, so let's start off by seeing how this works in Spring AI today. And to do that, we're going to create a new Java class. I'm going to call this the chat memory controller. And we'll go ahead and make this a REST controller. And then we'll go ahead and get a chat client. So I'll say private chat. Let's make this final chat client. We'll get this through constructor injection. We'll call this builder. And this is actually using the builder. So we'll say builder. And then we'll say builder.build. And that will give us what we need. Now we also need chat memory. So chat memory. This is a bean that Spring will wire up for us automatically. Because right now we only have one chat memory bean in the application context, this injection point will go ahead and inject that default chat memory. So with the chat memory, what I can do is create an advisor here. So we could say default advisors. And I could say message chat memory advisor. And that builder is going to take a chat memory. So I'll say chat memory build, and that will give us what we need. Now, if you want to learn more about advisors, I'll leave a link to a video I've done on advisors in the past. But you can think of these kind of like AOP around the LLM call. We're doing something. And so this chat memory advisor is giving us the ability to retain the conversation. Remember, large language models are stateless. The web is stateless. But products that sit on top of the large language model, like something like ChatGPT, that is what is remembering the context, the conversation that you have with it. And so we need to do that in our own applications as well. And so we come with this message chat memory advisor. This is storing it in memory. There are some other advisors you can use if you want to like store it in a cache or a database. You can do that as well. So with that, I can create a get mapping. So I'll say get mapping to /memory. And then what I can do is I'm going to return a string for this, and I'll just call this chat. And this is going to take in a request param. We'll call that message. So we can say request chat client. We'll prompt it. We'll give it a user prompt of the message that we pass in. We'll make a blocking call, and then we'll return the string content. So if we just do that, we should be able to run the application, and something is, we didn't get set up. So we need our OpenAI API key in here. So I'll say OpenAI API key, and I have this in an environment variable. So I can just go ahead and add that there. And let's run this again. And now I can go ahead and make some requests to 8080/chat. I'm using HTTP curl for humans, much easier to use if you ask me. So I'll say 8080/chat. The message I'm going to give it is my name is Dan. Okay. We'll see what it says. Did we not set up we did /memory. So let's say /memory. Okay. And it's going to say, hey, nice to meet you, Dan. Now, if I didn't add this advisor, the problem is if I said, what is my name without this advisor, it would have no idea because it's going to go, I don't know. I don't have any contextual context here of what we have talked about before. But because we've enabled this advisor, now it says, hey, your name is Dan. How can I help you today, Dan? And this is great. This works great out of the box. Now, if we look at this chat memory, we have a conversation ID, so we can tie it to different conversations. It has messages in here. There's a way to add, get, and clear messages. The default message chat memory advisor here has chat memory. So we pass in our chat memory, conversation ID, order, scheduler. This is all working. What happens though is we have a default message list, right? We don't want to just pass an infinite number of messages. And by default, I believe this is 20. You can look in the documentation. But what happens when we get to 20? Do we clear them all? Do we clear a few? There are some strategies that you can take to this. This by default will, I believe, clear them all. I have to look into that, actually. I don't know what that actually does. So what happens when we get to 20? We just clear them all. Now it has no context of it. If you've ever used something like Claude Code, this is the /clear command. When you're done working on a problem, you just want to clear out that context. You don't want to keep filling up the context window with a bunch of tokens that don't mean anything to what we're working on. But there's also a /compact command in Claude Code. And what that does is it takes a percentage of your conversation and then uses an LLM to basically summarize that. So let's say that we had 20 messages and we got rid of 15, summarize them into a conversation, and then now we only have 5 or 6 messages. So we're making that window, the context window, smaller, but still retaining some information. And so I thought about that and I said, well, that's probably something we can do, right? How can we go ahead and tackle that? So again, I'm going to kind of copy and paste some code, but we'll talk through some of it. So first I'm going to start with a package. I'm going to call this config. And in this config, I'm going to create a chat memory configuration. So what this chat memory configuration does is it will work off some properties. So let's paste those in too. And it will create some configuration. I still want to keep this regular chat memory around because what if I want to use one or the other? So when there's not one chat memory on the in the application context, we need to create these beans. So I'm going to create a bean for the regular chat memory, which holds a max message of 20. And then I'm going to create a new chat memory called compacting chat memory. And this will hold a max messages of 20 as well, but this will kind of work different. And then we just set up a primary model for the chat model because when we create a chat client, we may want to create a chat client from a different chat model. This one I have as the primary chat model, which is going to use OpenAI. And then what I'm going to do is I'm going to use Google Gemini and specifically their Gemini 2.5 Flash model, which is cheaper and fast. And so this will be a good use case for using that model to summarize messages in the window. So I think I need some properties for that. Let's go ahead and add those. So I'll come over here. Oops. And I believe we're not using GPT-5 here. So let's go ahead and do that. And then I have my summarization model, which is going to be Google. And to do that, I believe we'll have to add another large language model, or at least another starter here to our PaLM. Yes. So let's go in here and add that. Okay. So I think so far so good. The Google Gen AI chat model. Let's make sure we are on the latest version. So I did a video on this as well. This got a lot easier to use Google's models in your Spring AI applications. In this latest version, instead of using something like the Vertex API, we can now use the Google Gen AI API. So this just requires a API key. Okay, so this is where we need to create our compacting chat memory advisor. This is the new advisor that we're going to create. All right, the first thing I do here is create an advisors package, and I'm going to paste in this compact chat memory advisor, and we'll talk through it. So let's start here. We have some things that we are going to use, like max messages, what the compact threshold is, messages to compact. We're validating the configuration is set up. We want to make sure those values are configured. And then we have this advise call. So this is what kind of wraps around the request to the LLM. We first check and compact. So we want to check to see if we need to compact that. If the message size is above the compact threshold, we will perform compaction. So we get a list of messages from the messages, and then we are excluding out system messages. And then what we do is we filter those out and we get our user and our assistant message. So if you don't know, the assistant message is the response, and we take those and collect them. And what we do is then call out to the LLM to summarize the following conversation. So we are using the summary client, which is, again, the other chat client. We've created a new chat client called the summary client, which is based on the Google Gemini model in this case. You can put whatever a large language model you want as the main driver, and whatever one you want as the summarizer. They can be the same. They can be different. Whatever you want to do, you can kind of configure that. We also log out some summary tokens. We clear our old messages out and then add the summary in to the conversation. There's some more things going on, but essentially that's what we do. And then we go ahead and extract and add the user message to memory. So now that we've kind of summarized it, we're adding this new message to the window. And yeah, and then that's about it. So get conversation history and augment the prompt. We take our check client request builder. We add the prompt, build that out, and then we call next call to get the response. And then the chat memory, we add it using the conversation ID and the response there. So there's a little bit going on in here, but nothing too complex. So this is what allows us to create have the ability to, when we add a message to the chat memory, see if it crosses some threshold, and then go ahead and compact that. So I am going to, what's going on here? Compacting chat memory advisor. Yes. I think maybe this is an import issue. Yeah. Compact. Yeah, that's the problem. So that should be okay now. And that's that. So now we have a compacting chat memory advisor. So instead of using the regular chat memory advisor, we should be able to use this one. Now I'm going to go back to my properties, and we're going to put a couple more properties in there. So I will just throw these in, and I've put some comments on here so that we know what they do. But we have some max messages. So these are, I'm going to just still retain 20, but then I have a threshold. So 78% of that max messages, this will automatically trigger compaction when the conversation reaches this many messages. So again, these things are all configurable for you to decide. And then the messages to compact, we maybe don't want to compact all 15, right? We maybe only want to compact a certain percentage of that. And then if you want to turn on debugging to see what's going on in that advisor, you can. So that, I believe, is all we need. Yeah, let's create a new controller here. So I'm going to create a new chat. Actually, let's call this compacting chat memory controller, right? This will, again, be a REST controller, but we're going to wire this up a little bit different, right? So we need a chat client. So chat client. We also need the compacting chat memory advisor. We'll call this the compacting advisor, right? And let's create a constructor. Sure. This is going to be a builder. Let's close this. Get some things out of the way. And then we'll say builder.build. And then let's go ahead and do this. So now, actually, let's just do this for now, because I'll do this in the method just to show that as well. So, or no, we still want to do this. We might be using that somewhere else. So I do want to set the default advisor. So now all we need is the compacting advisor. We don't need to set it up the way we did before. So now we have that. So now I can say git mapping. Let's call this compact memory. And public string compact. This is going to return the chat client, the prompt, the user message, which we will want to pass in here. Then we will call and we will return the string content. Okay, so that looks pretty good. You could also, I think I added some, in the final version of this code, I also put some things in the controller. So if you wanted to trigger a compact automatically, you could just call /trigger. And if you wanted to clear the memory out totally, you could do that as well. So let's see if we can run this. And again, with debug on, we should see some things going on in the console. We need, consider marking one of these as primary. Which one of the regular chat memory defined by, oh yes. So in my previous example, I just said chat memory, but if we call this regular memory, that should get wired up. Chat memory, regular memory. There is more than one bean of type chat memory. There is, but I thought that if we named this regular memory, oh, regular chat memory, that's why. Regular chat memory, right? Still complaining. So this is weird because this is an injection point and it should see this by its bean name and automatically, oh, I spelled something wrong. That's why. Okay. So yeah, it sees it by the bean name, so you don't need to add qualifier there. So now it sees that one. This one should work. Let's try and start this again. Okay. So let's ask it some questions. Now, which endpoint do we say here? Compact memory. So HTTP 8080 compact memory and message equals what are the largest 3 states in the US? Okay. So hopefully we'll get some things there. Now, oh yeah, I'm not going to hit those thresholds. Well, 1, 2, 3, 4, 5, 6. We're going to have to ask it a few. So let's see. Okay, now again, and remember, it remembers context, so I can say, what is the capital of that state? And it knows what state we're talking about because we're retaining the information about it. So it knew we were talking about Ohio, so it's going to come back with Columbus. What is the smallest city in that state? Okay, again, we're just kind of working off context here, and then I'll check the debugger and see if we have gotten there yet. Because remember, it's not just my message, it's each additional response that adds to that memory. So I think that's 4 questions. That should be 8. That should trigger a compact, but we'll see. So let's just hop over. I want to see if this is happening. It looks like things are happening, right? Completed. Oh, we're not getting any debugging log. Oh no. So Dan Vega, CCM, advisors. So that is the debug level that we need to be on. So I just configured something wrong from the previous example that I showed. And did I restart? Let's restart this. And then I'll fast forward through this because you don't want to watch this again. Okay, so if we go over to run here, now you'll see a lot of the stuff that was going on at the debug level in that chat memory advisor, the compacting chat memory advisor. So checking threshold, adding user message, checking threshold, we get all the way down here and we see that we have the threshold 6 of 15, token 66, conversation ID, retrieve 7 messages for 75 tokens. So it doesn't look like it actually got into any of the compacting yet. But again, if you did it enough, it would. And so this is really just a project I started out of having some of those conversations at the conference. This is not something that's in Spring AI, but if you would like it to be, let me know. I can always talk with the team. But the nice thing about these advisors is you can build your own advisors, right? There are some built-in advisors like this chat memory advisor. There's the RAG advisors. There's the simple logging advisor, but you can create your own advisors. And this is just kind of one simple example of that. Seeing a problem, that I was having with the chat memory advisor and being able to go ahead and create my own. All right, that's it. The compacting chat memory advisor. I hope you learned something new today. I hope you got some things going on in your head there, thinking about some custom advisors that you can write. Hopefully this one will help you out. Again, all of the code that we went through today will be in the GitHub repository. I will put that in the description below. Also, if you kind of use this, let me know. Let me know if you have some questions about it. Obviously, you can file some issues if you have any. But let me know if you build any custom advisors yourself as well. So I'd love to hear that. Well, friends, you know what to do. If you learned something new today, I had a lot of fun putting this together. But if you learned something new, do me a favor, give me a thumbs up, subscribe to the channel. And as always, happy coding, friends.